In this video, we'll cover a brief introduction to Venn diagrams. Let's begin with an example that shows you a universal set, a subset, and a Venn diagram. A large university has 24,000 students. There are 4,513 business majors at this same large university. The set U is the set, in this case, of all students. This is called the universal set for this example. The set B is the set of all students who are business majors. This set is a subset of all the students at this large university. In the diagram that you see, the business majors are represented by the light blue circle. And you can see that the circle is contained entirely within the rectangle that's called U, the universal set. All other majors are represented by the area shaded in the dark blue color. So the universal set is made up of all the business majors that are in light blue and the non-business majors, which are in dark blue. That is, the elements of the universal set contain all elements that are within the rectangle. So there are some basic definitions and symbols you should be familiar with. The universal set is a general set that contains all of the elements under consideration for a particular situation. We were considering all the students at that university. That was our universal set. A Venn diagram is a visual representation which shows the relationship between sets. This was named after British logician John Venn. Now, we started with a very simple example, one for which you most likely would not have to have a Venn diagram to understand. But as relationships among sets become more complicated, it is important for you to be able to see a picture representation of how those sets are related. The universal set in a Venn diagram is represented by the area within a rectangle. Subsets of the universal set are usually represented by circles, but also may be represented by ovals or other shapes. So here is another example of a Venn diagram that shows a universal set and a subset. We're going to use the diagram below to describe the elements in the universal set, as well as those in the subset. Then we'll list the elements of each set in roster form. The universal set U consists of the natural numbers, that is the counting numbers, from 1 to 10. So the set U is the set of 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Because remember, the universal set consists of all elements in both the dark and the light area. That is, every element contained within the area of the rectangle. The subset S consists of the odd numbers from 1 to 9. Those are 1, 3, 5, 7, and 9. So what distinguishes the subset from the universal set, which is all natural numbers from 1 to 10, including 1 and 10, is the fact that the numbers in the subset are all odd numbers. And once again, it takes all elements that are within the rectangle to make up the universal set U. So the universal set is not just the even numbers that appear in the darker blue area, but it consists of those elements both in the darker area and the lighter area. So as we said, once again, the universal set is all of the natural numbers from 1 to 10. Now we'll look at some Venn diagrams with two sets, and this is where it becomes a little more complicated, and the Venn diagrams will be more helpful. Now, the first kind of set you may have when you have two subsets are sets that are called disjoint sets. So here you can see, represented by the Venn diagram, a universal set U, and within U there are two subsets, D and C. A class of 24 students was surveyed and asked, do you have a dog? Do you have a cat? Do you have both a cat and a dog? 10 students responded that they have a dog. 8 students responded that they have a cat. 0 students responded that they had both a cat and a dog. So you can see represented here the subset of students who have dogs. So that is why the value 10 appears in the subset D. 8 students have cats, and that's why the value 8 appears in the subset for cats. And no students have both a cat and a dog, so there's no overlapping. These are called disjoint sets. Now looking at this, we realize that there are only 18 of the 24 students represented by the subsets. So there must be 6 students who do not have a cat or a dog. Now those 6 students are within the universal set, which is the class, but not within either of the subsets, students with dogs, students with cats. So notice that the 6 is inside the universal set, but not inside either subset. Now, you'll be able to recognize disjoint sets because the circles do not overlap. Now, here is an example of a Venn diagram that represents a proper subset. And we've already talked about proper subsets. So this is exactly the same kind of proper subset we spoke of before, only this time we're looking at it in a Venn diagram. Once again, we have a universal set represented by U, and it contains all the elements within the rectangle. Those within those circles and outside of the circle. So anything within the rectangle is in the universal set. In this picture, we also see two subsets, a set D and a subset C that is drawn entirely inside the circle representing subset D. So this could describe a situation like this. A class of 50 students was surveyed and asked, do you use the internet at home? And if you do you use the internet for entertainment? Entertainment could be anything from Facebook to watching YouTube videos to watching Hulu or Netflix or anything like that. Anything for fun. U is the set of the 50 students, or all students in this situation. Happens to be 50 this time. D represents the set of students who use the internet at home. Now remember, sets are named with capital letters, and in this case, we're just using D to represent the students who have internet at home. C are the students who said, yes, I have internet at home, and I use it for entertainment. So this time, we're going to kind of work backwards. There are 28 students who responded that they have the internet at home, and they use it for entertainment. There were 48 students who responded that they use the internet at home. Now be careful here, set C is contained entirely in set D, so instead of writing a 48, we have written a 20, because remember, D is all the students who use the internet at home. It contains all of those 20 students plus the ones who use it at home for entertainment. So there's your total, 48 students who said, yes, I use the internet at home. And remember, there were 50 students total who were surveyed, which means 2 students said no to having the internet at home. So let's just review these numbers one more time to make sure you understand. We have a total of 50 students. 48 have said that they have the internet at home. Now, set D represents those 48 students. And so a second question was asked, and that was, if you do have the internet at home, do you use it for entertainment at home? And 28 said yes. Since the total has to be 48 and 28 have it at home and use it for entertainment, that means that 20 students do not use the internet at home for entertainment. That set D has to have 48 total students in it. You have to separate out the 28 that use it for entertainment, leaving us with 20 to make a total of 48. Now, if we were to write the number 48 instead of the number 20, we would have too many students in set D, because we would have 48 and 28, since set C is contained entirely within set D. And of course, there were 50 students, so there have to be 2 students who said they do not use the internet at home. And from our earlier discussion, we talked about proper subsets. Set C is a proper subset of set D because all of the elements in set C are also elements in set D. So in other words, those 28 students in set C have also said that they use the internet at home, which is what set D represents. But set C and set D are not exactly the same. And in order to be a proper subset, set C cannot contain all of the elements of set D. And remember from an earlier discussion, we talked about how you represent C as a subset of D. We used the notation that is the U on its side, and that means C is a proper subset of D. All of C is contained within D. However, C is not exactly the same set as set D. In fact, there are 20 more students in set D than there are in set C. Now let's look at an example of equal sets. A class of 80 students was surveyed and asked, do you have access to the internet at home? If yes, do you use the internet for entertainment? Set U is the universal set, and in this case is this set of 80 students who were surveyed. Set D is the subset of all students who responded, yes, they have the internet at home. Set C is the subset of students who responded, they have the internet at home, and it is also used for entertainment. Since 78 students responded yes to both of these questions, set D and C are exactly the same, and this makes them equal sets. And there are 2 additional students, of course, who don't have the internet at home because we have to have 80 students in our universal set. Again, these are called equal sets. They are represented by a single circle within the universal set rectangle. Here is an example that shows a Venn diagram where sets have some elements in common. A class of 40 students was surveyed and asked, do you have a Facebook account? Do you have a MySpace account? Do you have both? That is, both Facebook and MySpace. U is the universal set, and in this case, it's the 40 students who were surveyed. F is a set of students who responded that they have Facebook accounts. M is a set of students who've responded that they have MySpace accounts. So the set F is represented by the light blue circle on the left. The set M is represented by the yellow circle on the right. And the overlap area will represent the students who have both types of social networking accounts. 26 students responded that they have a Facebook account. 14 responded that they have MySpace accounts. And 10 students responded that they have both. And since 10 students have responded that they have both accounts, the 10 is written in the Venn diagram in the overlapping area of the circles. For set F of Facebook users, we have to have a total of 26 students contained within the light blue circle. Well, we already have 10 in the overlapping area, so we need 16 more. So set F consists of the 16 students who have just Facebook accounts, as well as the 10 students who have Facebook and MySpace. So you'll see that contained within set F, there are 26 elements. And that's the same as the number of students who responded that they have a Facebook account. Now we have to look at the MySpace. 10 students have responded that they already have MySpace. They also have Facebook, but they do have MySpace. Those 10 students have both. Since 14 have responded that they have MySpace accounts, we need 4 additional students or elements for set M. Set M now represents 14 students who have MySpace accounts, 4 who have only MySpace accounts, and 10 that have both MySpace and Facebook. Now, sets F and M have some elements in common, but not every element in common. So Venn diagrams are used to help us organize information and to answer questions about sets. And in this case, we are asked to use the Venn diagram to write the roster form of each set. So we're going to look at this universal set U, which contains 2 subsets, A and B. Those are represented by the capital letters. And the lowercase letters represent the elements that are inside those actual sets. Set A, which is a subset of the universal set, has 5 elements within it. Those elements are A, B, C, H, and F. Every element that is listed within the circle for set A must be listed in the roster for set A. Set B, represented by the yellow circle on the right, has 4 elements in it. Those elements are C, D, H, and I. And the universal set will contain all of the elements that are shown within the area of the rectangle. So that will include the elements of set A, the elements of set B, and the other elements that are not contained in sets A or B, but are still within the universal set. So those elements are actually A, B, C, D, E, F, G, H, I, J, and K. Set C, we're asked to find the elements in set A that are not in set B. So the elements that are in set A that are not in set B are those that are not within the overlapping area. So those would be elements A, B, and F. Set D, the elements that are in both sets A and B. And in this case, to be in both sets, the elements must be shown in the overlapping area. So those elements would be C and H. And finally, set F is the elements that are in neither A nor B. So we are looking for the elements within this universal set that do not lie within sets A or B, and those are the elements E, G, J, and K. Another example. A pet survey was conducted and the results are shown in this Venn diagram. Answer the questions. So the first thing we want to do is just kind of look at our Venn diagram. We see we have a universal set. And along the bottom, we can see what each of these sets represent. In this case, our universal set, is pet owners who were surveyed. The set D is a set of dog owners, and the set C is a set of cat owners. Our first question is, of those surveyed in our universal set, those people who were surveyed, how many own a dog? Then we want to know, of those surveyed, how many own a cat? Next, how many have both a cat and a dog? How many have neither a cat or dog? And finally, how many were surveyed in the first place? And now we can use the Venn diagram to answer all of these questions. How many of those who were surveyed have a dog? So notice that the blue circle represents the dog owners, and that there are 60 and 44 survey responders who said they have a dog. That means that of those surveyed, 104 have dogs. Now, how many have cats? Well, the cat owners are represented by set C, and you can see that there are 84 and 44 who responded to having cats. That's 128. The next question, how many have both? Well, in this Venn diagram, that center section where the sets are overlapping represents those who responded to having both a dog and a cat. That's 44. And next, the number of survey responders who say they had neither is 12, because the 12 is not located within either the set for dog owners or the set for cat owners. And then we come to the question about how many people were surveyed. And if we were to just look at the words that are written here, 104, how many own a dog? 104. How many own a cat? 128. How many have both? How many have neither? How many were surveyed? You might get a little bit confused. But when you have your Venn diagram set up appropriately, all you have to do is add the numbers that you see. 60 and 44 adds up to 104. Add the 84 for the cats. That's 188. Add the 12 additional people surveyed who said they don't have a cat or a dog. That is 200. So the total number of people participating in the survey was 200.